Hi everyone, this video is on simplifying using rational exponents along with our other exponent rules. So we're going to bring everything together that we've talked about in our previous two videos. So if I was to simplify x to the fourth y to the negative 6 over 5, I'm going to raise that whole thing to the negative 1/2 power. We're going to want to simplify this using exponent rules first. Then we'll worry about the rational exponent at the end. So using our exponent rules, if I see simplifying the inside, a negative exponent in the numerator, that tells me to move to the denominator, move that base to the denominator, and then make the exponent positive, right? So I can write this as x to the fourth over 5y, and now make that a positive 6, right? This is what the negative exponent tells us to do. On the outside, this is still to the negative 1/2 power. Don't lose that. And then once you have that, when you have a negative exponent on a fraction, our rules for that tell us that you can take the reciprocal of the inside and then make the exponent positive. In other words, I have 5y to the 6th. You flip the inside over x to the fourth, and then the exponent that was negative now becomes positive, so the positive 1/2. And then if you remember from our exponent rules, we talked about, well, if you have a power on the outside of things are being either multiplied or divided in here, you can bring that power to each piece individually. So I can really write this as 5 to the 1/2, y to the 6th to the 1/2 power, and x to the fourth to the 1/2 power. And to simplify that down, keep in mind how this works. You're going to, for 5 to the 1/2, you really can't simplify that any further, so I'll keep it as 5 to the 1/2 for now. For y to the 6th to the 1/2, remember, when you have a power to a power, you multiply these. So this is 6 times 1/2. Well, 6 times 1/2 is really, when you multiply a whole number times a fraction, you multiply it right to the numerator. 6 times 1 would be 6, divided by 2 would make that 3, so this ends up being y to the third. Over here, x to the fourth to the 1/2, again, you're multiplying the exponents. 4 times 1 is 4, divided by 2. So x to the 4 divided by 2 is just x to the 2, right? Because 4 divided by 2 is 2. And then, you really can't simplify this any further. You might want to get rid of the 1/2 here and write this as a root again. Remember, the y to the third is separate from the 5 to the 1/2. So this 1/2 only belongs to the base of 5. Well, 5 to the 1/2 power, that means the power you're going to put on is 5 to the first power. And the 2 is, remember, in the denominator is the index of the root. So it means take the square root of 5 to the first power, which I'll write as square root of 5. Y to the third stays y to the third. It's not under the radical. And then x squared stays x squared. And to simplify this, you can leave it like this, but typically we write things that are not under the root first. So I have y to the third square root of 5 over x squared. And I can't simplify that any further. The square root of 5, remember, isn't a perfect square, so if we want the exact answer, you have to leave it like that. Don't type it into your calculator. The exponents are all positive, which is good. Remember, that's part of being simplified. And all of my bases only show up one time, so I've simplified that completely. Let's take a look at another one, and let's use this one here. If I said I had 3x squared z to the 3/5 over z to the negative 2/5, and then we're going to raise that to the 1/4 power. So you might want to try this on your own. If not, you can do it together with me here in the video, but if you want to pause it and then try it and then come back, that's fine. Taking a look at this, let's simplify the inside first, just like we did in the last one. Simplifying the inside here, 3 is in the numerator, it doesn't have anything to divide with, so it'll stay 3 in the numerator. X squared, again, doesn't have anything to divide with, it's in the numerator, it'll stay there. Z to the 3/5 divided by z to the negative 2/5. Remember, when you're dividing things with the same base, you subtract their exponents. So the exponents here would be 3/5 minus, and then you're subtracting a negative 2/5. Remember what that means. If I'm subtracting a negative, it really means that you're going to add these, right? So this becomes 3/5 plus 2/5, which equals 5/5, which really equals 1. So the exponent on z, when you do this division, is just z to the first power. And then this whole thing is being raised to the 1/4 on the outside. So when you divide things with the same base, remember, you subtract their exponents. 3/5 minus is because you're dividing, so you're using subtraction. And then the negative 2/5 because there's a negative sign on there. So minus a negative really makes this, right, 3/5 plus 2/5, which equals 5/5, which equals 1. Now once you're here, we can kind of do what we did in the previous example. We'll bring that 1/4 to each piece individually. This will give us 3 to the 1/4, x squared to the 1/4 power, and z to the 1/4 power. All right, so I'm bringing each base to the 1/4 power. And then simplifying this, well, 3 to the 1/4 doesn't simplify. I'll keep it as 3 to the 1/4. X squared to the 1/4. Remember, when you're doing this, you multiply exponents and you raise a power to power. So it's 2 times 1, which would be 2 over 4. So 2 over 4 would reduce to x to the 1/2, right? So when you do 2 times 1/4, it'd be 2 times 1 is 2 divided by 4. 2 over 4 is the same as 1 over 2. So make sure you reduce that. And then we have z to the 1/4. Well, it doesn't reduce any further. So here's what I'm left with. Neither of these 3 to the 1/4 or z to the 1/4 simplify. The x to the 1/2 is simplified completely, but they're different roots, right? This is the 4th root of 3 is what that really means. All right, remember the bottom number in your rational exponent, the denominator, tells you about the index of the root. The power on 3 is 1, so it's the 4th root of 3 to the first power. X to the 1/2 means the square root of x. Make sure you don't put any index there because that 2 is imaginary, but it's the square root of 2. And then z to the 1/4 will be the 4th root of z. So to simplify this, you can write this as, all right, the 4th root, since they're the same index, you're allowed to multiply those together and put them under the same root. So it's really the 4th root of 3 times z and then times square root of x, which will be separate. So it's really the square root of x times the 4th root of 3 times z. You can't bring that square root of x into there because the indexes are different, or the indices are different. So keeping that in mind. This will be helpful later on when we get into the next sections. Let's take a look at just a few more. If I said I had 2x to the 2/3 times 3x to the 1/2 plus 4x to the 3/4. So don't let this throw you off. This is something you've seen before. We're just now working with rational exponents, but this means multiplication, right? It means take 2x to 2/3 times, in parentheses, the 3x to the 1/2 plus 4x to the 3/4. And what we would previously do, what we're going to do here is we're going to distribute. So I'm going to distribute 2x to the 2/3 through to each term inside of here. So when you multiply two things, right, 2 times 3, the coefficients just multiply as normal, so it gives us 6. And for the things with the same base, when you multiply them together, you add their exponents. So it's x to the 2/3 times x to the 1/2. It'll be x to the, you add the exponents, 2/3 plus 1/2. I'll simplify that in a minute, but just have an understanding of where that comes from. And then distributing through here, plus 2 times 4, the coefficients give me 8. X to the 2/3 times x to the 3/4. Again, when you multiply things with the same base, you add their exponents. So this will be 2/3 plus 3/4. Now you need to simplify these exponents. You don't want to leave them as they are there. So, we're going to simplify these to a single exponent. So this gives us 6. Now 2/3 plus 1/2. What you need when you add fractions, remember, is a common denominator. So some of the stuff that we've talked about previously never goes away. So 2/3 and 1/2, the common denominator is 6. 2/3 is something over 6. Well, 3 times 2 gets you 6, so 2 times 2 gives you 4. So it's 4 over 6 plus 1/2. Well, 2 times 3 gives me 6, so 1 times 3 gives me 3 there in the numerator. So this first fraction will be 6x to the 4 plus 3 is 7 over 6, and that's the first term. Plus, here doing the same thing for the 8x to the 2/3 plus 3/4. Well, x is still the base. Common denominator when you add these fractions for 3 and 4 is going to be 12. So I want to write 2/3 as something over 12. Well, 3 times 4 gave me 12, so 2 times 4 is what you do in the numerator, which gives you 8. Plus here in the denominator, 3/4, writing it as something over 12. Well, 4 times 3 gave me 12, so 3 times 3 gives me 9. So this will be plus 8x to the 8 twelfths plus 9 twelfths is 17 twelfths. You could leave it like this. I'd be okay with that. If you wanted to write these as roots, you can write them that way as well. What you can't do is you can't combine these, right? Because these aren't like terms. These x's are to different powers. Remember, like terms would have to have the same base with the exact same exponent. So you can't combine these. So writing this just as some roots, just so you can see it, this will be 6, and then here we have, this is what root? Well, it's the 6th root, because 6 is in the denominator, of x to the 7th power, plus here 8, x, we're taking the what root? The 12th root of x to the 17th power. So either of these is okay for now to leave as the answer. Keeping in mind though that when you do this, and that's a 12 there, make sure it's clear. Keep in mind when you do this, later on we're going to simplify these. Whenever you see that the power inside of your root is higher than that of the index, you will be able to simplify these further. This will be coming up in the next section, so I won't get into it now. But that's where you would simplify it further, is how you can simplify those down. Let's just take a look at a couple more. I just wanted you to see that previous one just to make sure you understood how to distribute through and then combine the exponents. Let's take a look at just 2 more. You may want to try these 2 on your own. If I said to simplify, and the first one here I'll put is the 9th root of a to the 6th, b to the 9th, c to the 3rd, and that's all raised to the 3rd power. And the second one I'll put here is the 8th root of 9x to the 10th, y to the 12th, z to the 2nd power, and that's all raised to the 4th power. So you may want to pause the video, try these on your own, and then check your work. So let's simplify this. So for the first one here, first thing I would do is, notice that if I'm looking at this 3 on the outside could be brought to the inside, and I can simplify those exponents. Now, you don't have to do it that way. You could also, if you wanted to, the first thing you could do is rewrite this as, the power over the root. Either way is okay. Now, if we did it that way, the base is everything inside here. So you'd have a to the 6th, b to the 9th, c to the 3rd. And then if you want to write this as a rational exponent, you would write this as 3 over 9. Right? Because 3 is the power over the index of the root, which is 9. Now if you do that, 3 over 9 reduces to 1/3. That's what I would do next. So we got a to the 6th, b to the 9th, c to the 3rd, and this is to the 1/3 power. And then remember, when you have multiplication inside of here all being raised to power, you can bring that power through to each piece individually. So this would be a to the 6th to the 1/3, b to the 9th to the 1/3, and c to the 3 to the 1/3. And now remember, when you have power to power, you multiply them together. So this is a to the 6 times 1 divided by 3. So it's a to the 6 times 1 is 6, divided by 3 is 2, so this is a squared, right? Here we got b to the 9th to the 1/3 power. 9 times 1/3, well, it's 9 times 1 is 9, divided by 3 will give us 3, so this is b to the 3rd. And then c to the 3rd to the 1/3 power, 3 times 1 would be 3, divided by 3 gives us c to the 1, which would just be c. So you get a squared b to the 3rd c when you simplify that. Looking at the next one, we can do something similar here. Right, you know that when we have this index of 8 and the power of 4, we can raise everything inside of here to the power over the root. So the base is the 9x to the 10th, y to the 12th, z to the 2nd power, all raised to the power of 4 over 8, which was the index, so the 4/8 power. 4/8 reduces, right, in the exponent there, so we have 9x to the 10th, y to the 12th, z to the 2nd, And then 4 over 8, remember that reduces to 1 over 2. Make sure you reduce this properly, right? Don't say it's 2, right? It's 4 over 8, so that reduces a fraction to 1/2. And then again, you can bring that power through to each piece in here because it's multiplication of the bases. You only can do this if it's multiplication or division. So we have 9 to the 1/2, x to the 10 to the 1/2, y to the 12 to the 1/2, and z to the second power to the 1/2. And we're going to simplify these. Well, if I write 9 to the 1/2, that doesn't work the same way as these variables do in terms of the way you would handle it. So 9 to the 1/2 really means, well, what am I doing here? 9 to the first power and then taking the square root. So it's the square root of 9. We'll simplify that in a minute. Actually, we can do it right now. What's the square root of 9? Well, the square root of 9 is just 3. So we know that first term, or that first factor simplifies to 3. X to the 10th of the 1/2, well, remember what you do, a power to power, you multiply these. So 10 times 1 is 10 divided by 2, which makes that x to the 5th. Right? Y to the 12 to the 1/2, remember power to power, you're multiplying. 12 times 1 is 12 divided by 2, that'll make that y to the 6th, right? 12 divided by 2. And here we'll have z to the 2 times 1 divided by 2. 2 divided by 2 gives us just 1, so z. So we get 3x to the 5th, y to the 6th, z, and you leave it like that. Remember, the square root of 9 we took because the 2 was the index here, so it tells you take the square root. If you evaluate that, it comes out to 3. Don't write the root again. You've already evaluated it there. Each of these, because we had a power to a power, we multiplied and then simplified. In the next sections, we'll talk about how to simplify these if they don't come out perfect. Kind of like the last example you saw on the last page, where these roots didn't divide out evenly, right? Those powers didn't divide evenly. And we'll talk about how to simplify in those cases as well.